Dear children, welcome to chapter Quadrilaterals, session 1. In this video, we shall see what are quadrilaterals and their types, and also we have to prove the properties of a parallelogram. Do you know what are quadrilaterals? Yes, quadrilateral is a planar closed figure formed by joining four non-collinear points. Collinear points, points which are on the same line are known as collinear points, and non-collinear points are the points which are not on the same line. So, take four non-collinear points A, B, C, D. Now join them AB, BC, CD and AD. Then we will get a closed planar figure. This is known as a quadrilateral. Now, what are the properties of quadrilateral? It has four sides and four vertices and four angles, and also two diagonals. And we know the sum of four angles is equal to 360 degree. Right? Now write down in the figure ABCD is a quadrilateral. Here four sides are AB, then BC, CD and AD. And what are the four vertices? Four vertices are A, B, C and D. And what are four angles? The four angles are angle A and angle B, then angle C and angle D. And two diagonals in the figure AC and BD are the two diagonals. And sum of four angles is equal to 360 degree. Take any one quadrilateral and can you say sum of four angles of a quadrilateral is equal to 180 degree? How can you say to 360 degree? Yes, if you join one diagonal of the quadrilateral, then take this as angle 1, 2, 3 and this is 4, angle 5 and angle 6. You know, sum of three angles of a triangle is equal to 180 degree. So 180 degree plus 180 degree is equal to 360 degree. Right? Now I will show some types of quadrilaterals. You have to identify them and also recall the properties of them. Right? Yes. See, in figure 1, ABCD is a quadrilateral, and such quadrilaterals are known as what? Yes, correct. It is a trapezium. This is a trapezium. Can you tell me the property of a trapezium? Yes, one pair of opposite sides are parallel. These two sides are parallel, AB parallel to CD. Now, in the second figure, PQRS is, yes, correct, it is a parallelogram. Yes. Now recall the properties of a parallelogram. Opposite sides are equal and parallel. and opposite angles also equal. Then so many other properties have parallelograms have. Later we will discuss about it. Next, third quadrilateral is correct. It is a rectangle. And recall the property of rectangle. Rectangles, opposite sides are equal and parallel and all angles are equal and it is equal to 90 degree. Then fourth one, it resembles a parallelogram and its all sides are equal to. Therefore, this is known as rhombus. This is rhombus. Yes. All sides are equal and opposite angles are equal. Again, one more property is what? In a rhombus, diagonals bisect perpendicularly. Then fifth one, ABCD is a square. You know why it is square? All sides are equal and all angles are equal and it is equal to 90 degree. Then sixth one, it is what? See here, adjacent sides are equal. AD and DC are adjacent sides and these are equal. Similarly here, AB and BC are adjacent sides and these are equal. Such type of quadrilateral is known as what? Correct, it is kite. Right? Now, write down what are types of quadrilaterals. Rectangle, then square, parallelogram, rhombus, trapezium and kite. Yes. Next, some notes. These are very important. A square and a rectangle and also rhombus are all parallelograms. How? Say square, rectangle and rhombus. This is a square. Then take one rectangle and one rhombus. These are all what? A square, rectangle and rhombus. This is square, rectangle and rhombus. These are all parallelogram. Why they are parallelogram? Because what is the property of a parallelogram? Opposite sides are equal and parallel. Yes. Do the property holds good here in square? Yes. Opposite sides are equal. See here, opposite sides are equal and also parallel. And here, opposite angles are equal. Right? See here also, opposite angles, are they equal? Yes. Here also they are equal. Therefore, a square is a parallelogram. Right? Similarly, a rectangle is a parallelogram because opposite sides are equal and parallel, just like a parallelogram. Here opposite angles are equal. See, these opposite angles are equal. Here also opposite angles are equal. Therefore, a rectangle also a parallelogram. Then this is a rhombus. Is it a parallelogram? Yes, here also opposite sides are equal and parallel. See here, opposite sides are equal and parallel, as well as opposite angles are also equal. Here also opposite angles are equal. Therefore, rhombus is also a parallelogram, right? And continue here. See, the statement is continued in this way and not vice versa. That means what? A parallelogram is not a square, right? Why it is the parallelogram is not a square? In a square, all sides are equal and all angles are equal. Here, all sides are not equal and all angles are also not equal. Therefore, a parallelogram is not a square. Similarly here, a parallelogram is not a rectangle. Here also, see, opposite here, opposite sides are equal. This holds good. Opposite sides are equal. But here, all angles are equal. But here, only the opposite angles are equal. Therefore, a rectangle is not a parallelogram. Similarly here, a rhombus, a parallelogram is not a rhombus. Why? All sides are equal in rhombus, but in parallelogram only the opposite sides are equal. Therefore, parallelogram is not a rhombus. Right? Next, let us see second note. What is that? A square is a rectangle and also a rhombus. I will show you. A square. Take one square. You know the property of square? A square. Is it a rectangle? Is it a rectangle? See here. What is the property of a square? Square. In a square, opposite sides are equal. Do you agree? Opposite sides are equal. Here also, this side is equal. Opposite sides are equal. Therefore, a square is a rectangle and all angles are equal. In both cases, all angles are squares. All angles are equal. Here also, all angles are equal and it measures 90 degree. And it is also a rhombus. Do you agree? Square is also a rhombus. How? See here, in square, all sides are equal. Here also, in rhombus, all sides are equal. And here, opposite angles are equal. In square, opposite angles are equal. Right? Here also opposite angles are equal. Therefore, a square is a rectangle as well as it is a rhombus. Right? And not vice versa. How? See here, a rectangle is not a square because in square only the opposite sides are equal, right? But here all the sides are equal. Therefore, a rectangle is not at all a square, right? Similarly, even though angles are same, sides are not equal. Only the opposite sides are equal in rectangle. Therefore, a rectangle is not a square. Similarly, a rhombus is not a square. Why? Because even though all the sides are equal, but here only the opposite sides are angles are equal, and in square all angles are equal. Therefore, a rhombus is not a square. Right? Now next let us see third note. What's that? A square. A parallelogram is a trapezium. Write down a parallelogram. This is a parallelogram. Is it a trapezium? Yes, sometimes it is a trapezium. Why? Because one pair of opposite sides are equal. Here also one sides opposite sides are parallel. Therefore, a parallelogram is also a trapezium, but it is not vice versa. Means what? A trapezium is not a parallelogram. Why? In trapezium only one opposite sides are parallel, but here two opposite sides are parallel and they are equal. Opposite sides are parallel and equal. Therefore, trapezium is not a parallelogram, right? Here is a very interesting question. We have a rectangle and a parallelogram with the same perimeter 18 centimeter. Which will have more area? See, two are quadrilaterals and one is parallelogram and another one is a rectangle. See, one is parallelogram, another one is rectangle. Both have same perimeter. See, this is 5 centimeter and this is 4 centimeter. So perimeter is same. Here this is 5 centimeter and this is 4 centimeter. Then which will have more area? Yes. How can you say? See, ABCD is a rectangle. So area of the rectangle is given by length into breadth. So AC into AD into BC, AD into AB. That means 5 into 4 is equal to 20 square centimeter. And let us see here what is the area of the parallelogram. Now ABCD is a parallelogram. Draw perpendicular to the base AB. Let it be ADE. Now area of the parallelogram is given by base into height. So AB into DE. Here we can easily say DE is less than AD. So it is less than 4. So AB is equal to 5 here. AB is 5. DE is what? Less than 4. So answer also it is less than 20 square centimeter, right? So which will have more area? Rectangle has more area. Why? Even though their perimeters are same, rectangle has more area than a parallelogram, right? That is why we can observe this application in a sweet stall. Generally, sweet shopkeeper cut the burfis in the shape of a parallelogram and to accommodate more pieces in the tray. See the shape of the burfi before you eat in next time. Now let us prove the property of parallelogram. A diagonal of a parallelogram divides it into two congruent triangles and the opposite sides are equal. See, these are the two properties of a parallelogram. Let us prove the two properties together. Write down. This is a theorem. Take down this statement, and to prove any theorem we have to draw the suitable figure. So we need one parallelogram. Name it as ABCD, and here it is given diagonal of a parallelogram. It is given. So draw any one of the diagonal. Now I will choose AC diagonal. So join AC. So what is given? Given in parallelogram ABCD, AC is what? Is a diagonal. Next we have to prove. So to prove is what? It's given here. See, this is imaginary part of the theorem, a diagonal of a parallelogram. If you draw a diagonal of a parallelogram, then it divides it into two congruent triangles. So, after the imaginary part, this is the conclusion part. So, this is known as to prove part. So, it divides what? It divides it into two congruent triangles. So, triangle ABC is congruent to triangle ADC. So, how can we prove? Right. Next, proof. Yes, we have to select two triangles and then we have to say the two triangles are congruent. Write down. In triangle ABC and triangle ADC, what do you know? See, AB is parallel to DC. In parallelogram, opposite sides are parallel. So, AB is parallel to DC. And imagine AC is a transversal. Then, if a transversal intersect two parallel lines, then these angles are equal because these are alternate interior angles. So these two angles are equal. Now write down. Yes. AB parallel to CD and let AC is a transversal. Then angle, which two angles are equal? See, I will mark here. These two angles are equal. Angle BAC is equal to angle DCA. And why are they equal? Because they are alternate interior angles. Interior angles. Again, AC is common to both the triangles. See, AC side is common to both the triangles. Therefore, write down AC is equal to AC. Reason is what? Common side. And again, can we say BC is parallel to AD? Yes. Why? Because ABCD is a parallelogram. So, opposite sides are parallel. So, again, BC parallel to AD and AC is the transversal. Then, which angles are equal? See, this angle and these angles are equal. Now, I will mark the angles. These two angles, double marked angles are equal. Again, write down ABC parallel to AD and AC is a transversal. Then which two angles are equal? Angle, double marked angle BACB is equal to which angle? Yes, angle, correct, angle ACD or angle DCA. ACD. Reason, alternate interior angles. Write down the reason. Alternate interior angles. Interior angles. Right? Now see here, angle, side, again angle. A S A. A S A congruency rule. These two triangles are what? Congruent. Therefore, write down. Therefore, which two triangles are congruent? Triangle ABC is congruent to triangle CDA. Congruent to triangle CDA. Reason is what? Angle, side, angle, similarity, congruency rule. Once if you are able to say the two triangles are congruent, then their corresponding parts are also equal. That is, AB is equal to CD and also BC is equal to AD. These are what? These are opposite sides of parallelogram. Now write down. Therefore, AB is equal to CD and also BC is equal to AD. Read the reason. Corresponding parts of congruent triangle CPCT. Hence, we proved this theorem. Yes. Today, this is enough. Thank you.